Problems 3 and 4, we're going to use the limit theorems. We need to justify each step to prove what the limit is. So this first one, we want to find, if I wanted to, I could plug this into my calculator and find the limit, and that would at least help me with a head start and give me an idea of where I'm going. So that's something you could do. I'm not going to do that for the moment. The limit as x approaches negative 2 of 5x squared plus 7x minus 6x plus 2 over x plus 2. If we plug in negative 2, the denominator is going to be 0 because negative 2 plus 2 is 0. And we also get negative 2 squared is 4, so 4 times 5 is 20. And negative 2 times 7 is going to be negative 14. Minus 6, that negative 14 and negative 6 is negative 20. So 20 plus 20, this is going to be 0 over 0. That's our indeterminate form. So even if I use the limit theorems as it is now, I'm still going to get that indeterminate form. So I need to factor and cancel. So I want to rewrite this as the limit as x approaches negative 2 of these product on top, and it's going to be x plus 2 on the bottom, and we're hoping that we get an x plus 2 over here that we can factor out. So what do we multiply 2 by to get negative 6? Negative 3, right? And what do we multiply x by to get 5x squared? 5x. Okay, and then I'm going to FOIL this to make sure it works. X times 5x is 5x squared. X times negative 3 is negative 3x, and 2 times 5x is 10x. So the 10x and the negative 3x become the 7x. 2 times negative 3 is our negative 6, so that works. And then we can cancel this out, and we can rewrite this as the limit as x approaches negative 2 of 5x minus 3 as long as x does not equal negative 2. Right? My justification for all that is factoring and simplifying. Okay. Now I can rewrite this as the limit as x approaches negative 2 of 5x minus the limit as x approaches negative 2 of 3. Right? And even though it's a subtraction, subtracting and is the same as adding a negative, so you can make this plus. I can make this plus limit as x approaches negative 2 of negative 3, whatever, it doesn't matter. Then the limit theorem, the property that allows me to do that is the limit of sum of two functions, but you can just leave it like this. Right? Here I have the 5x, and I'm going to pull that out to the front of this limit, and it's going to be 5 times the limit as x approaches negative 2 of x plus, and I'll leave this one the same, x approaches negative 2 of negative 3. You could make that just 3 if you wanted and use the limit of a constant function right now if you wanted, but all I did so far was limit of constant times a function. Right? Now the limit of x as x approaches negative 2 is negative 2, so this becomes 5 times negative 2 plus negative 3. Right? And I use two properties there, limit of identity, and I'm just going to leave it ID, and limit of a constant. Okay? And I'm running out of space here. Can you see? Yes, you can. So I'm going to go down here a little bit, but 5 times negative 2 is negative 10, plus negative 3 is negative 13. And that's just a simplification. Alright, the next one's a little bit easier because we don't have to factor. The limit as x approaches positive 2, we can leave it at that this time. Again, I can plug it into my calculator and see what it is. This one's pretty simple. I'm just going to rewrite this as the limit as x approaches 2 of x times the limit as x approaches 2 of x. And then I'll say plus the limit as x approaches 2 of 3x minus the limit, or plus the limit of negative 4, right? Either way, as x approaches 2. And I use two properties there. One is the limit of a product, because x squared is x times x. So limit of product, and limit of a sum to split these all up. And then I can use, I can do a couple at the same time again. I'm going to use limit of identity, so this is 2. Limit of x as x approaches 2 is also 2, of course. This I can change to 3 times the limit as x approaches 2 of x, minus, and why not use the constant, limit of a constant right now. So I just used 3 limit properties. One was limit of identity function. One was limit of constant times a function. And one was limit of a constant. Oops, there you go. Okay. Now all I have left is this one more identity, so this is 2 times 2 plus 3 times 2, because the limit of x as x approaches 2 is 2, minus 4, and all I did there was limit of identity. Right, now I can simplify this. 2 times 2 is 4, 3 times 2 is 6, so that's 10 minus 4 is back to 6. Simplify. And there's worksheet 1.
Hi guys, this is Mrs. Thompson. Thanks for letting Mr. Thompson come to Australia with me. Cheers.